Hey, this is Mr. Buss, and I'm going to talk about how to do Lab 9, Wind Chill. The purpose of this lab is to determine the effect wind has on an object that is warmer than the air temperature, and determine the effect of wind on an object that is at room temperature. So for this lab, we're going to basically need to set up one of these structures, 2 clamps holding 2 of these clamps, and then you'll need 2 Erlenmeyer flasks. We just use the 250 ml size. That's all we have in the room. And then with a rubber stopper with a hole in it so that you can put a temperature probe in each of these. And then of course you'll need a LabQuest device, and you will be connecting to your iPad for this experiment. You'll need a fan and a towel. All right, and in order to run this, basically what you're going to do is you're going to take your Erlenmeyer flasks and fill them up with equal amounts of warm water. I would probably go 200 milliliters of warm water in each. That way the temperature probe, the tip of the temperature probe will be submerged. And make sure to run the warm water out of the sink for at least a minute or so to get it as warm as possible, because you want to have the starting temperature be at least 40 degrees Celsius. You know, room temp is about 20 to 25 degrees Celsius depending on the season. So you want something as warm as you can get. So run the warm water, fill it up to 200 milliliters. Okay, as you can see, I filled up the water in the Erlenmeyer flask to 200 milliliters. Did that for each of them. And I also dried the outside of the Erlenmeyer flask with a towel to eliminate any water on the outside of it, because you don't want to have it have evaporative cooling loss. It just should be dry on the outside. And then I want to have a pretty reasonably warm temperature. So again, over 40 degrees. So I'm at 44.5 for both. Perfect. You want them to be as close to identical as possible, so they are identical, so that's great. We're going to run the experiment, but I got to set it up first, of course. So we've done this similarly in the past, where we're going to run this for 10 minutes. So I'm going to run rate as 0.1 samples per second. That changes the interval. That's fine. And then the duration, again, I'll just 10 minutes, but I'll input that as 600 seconds. All right. Okay. Very good. So what I'm going to do then is I'm going to hit play and put the fan on high speed on one of these 2 conditions, because we want to know what the difference is in cooling is between the one with the fan and one without. So let me turn the fan on. I'll turn it on high just to get as much wind as possible on one of them, and I'll hit play on the device. Alright, so that's started. Got the wind running here. Feel it going on the Erlenmeyer flask. And then this one is not in the wind. After the experiment runs for 10 minutes, turn the fan off. Alright, and then on your LabQuest, I only ran it for a short amount of time because I'm just doing a demo. On the LabQuest, save your run. So now you should be on run 2. And run 2 is the effect of the cold water in the wind and not in the wind. So dump out the warm water, replace it with cold water from the tap. Okay, so I've replaced the warm water with cold water. Again, I use the towel to dry off any excess water. I also, I rinsed the cold water through a few times just because, I wanted to make sure it was actually cold water. The room temperature was about 21, 22 degrees Celsius. And looks like I'm pretty close to that. I'm at 23 degrees Celsius for my starting temperature for both of these. All right, on run 2, I'm going to go ahead and just basically run this again, 10 minutes. Turn the fan on, high. And then there's my part 2 of this. All right, since I'm just doing a demo, I'm just going to stop it, pretend 10 minutes have gone by. And then on your LabQuest, basically, when it's all done with the 10-minute run, view all runs, and then you should have, my graph isn't very nice since this is a demo, I didn't actually run it, I just kind of started and stopped it right away. You should be able to compare your data for warm water in the wind, warm water out in the wind, cold water in the wind, cold water not in the wind, and include that in your write-up. Perfect. Let me know if you have any questions.